How's it going, you guys? So since you guys have all been probably pretty recently introduced to Lisp or Common Lisp, I thought it would be really good to go over some of the tooling that you would want to use in order to create a fully featured project. Now, while languages like Go and Rust kind of offer an all-in-one solution that's actually part of the language, Common Lisp, just like the syntax, is very built around being extensible, and so it's a lot more abstract on how projects work. And so as a result, we have quite a few different tools that are actually used within the Common Lisp community to create projects. So in this video, we'll be covering how you guys can handle getting external libraries, how you guys can handle actual project management, and how you guys can compile executables. This should give you a pretty good basis for creating pretty much any program that you'll want to start out with making in Common Lisp. So just starting out, everything I'm going to be doing right now will be manually, but at the end of the video, I'll go over some ways that you can automate this and use some programs that will basically allow you to generate these template projects if you guys don't want to kind of start from scratch yourself every single time. So in this video, we'll be creating a very simple REST-based API. So you basically, if you're wondering what that means, this will just be a simple web-based application. So first things first, let's create a directory for a project to be in. So I'll just run the command mkdir, and then we'll call this basic. You can call this really whatever you want to call it. That's just what I'm going with for now. Now we'll go inside of the directory. Now it is worth noting that a lot of people like to keep all of their Common Lisp code under the home directory under Common Lisp, and then they would make their projects under here. I don't really like to do that. I like to just go with use a single directory for all my projects. But if you'd rather do this, this is also an option, and it will allow you to skip one of the steps later on. So now we'll want to make another subdirectory in our basic test directory. We'll just do make.dir, and we'll call this src. So this is where all of our source files will go. All right, now we'll go ahead and make our first source file, and we'll call this main.lisp. Now, once we've done this, we'll probably want to actually start up a REPL, so we'll just run sly. If you guys don't have sly installed or set up, you guys can go ahead and take a look at my previous video on installing and setting up sly. So now that we have gone ahead and started up sly, we will go ahead and create our first package. You can think of packages as basically namespaces if you guys are used to C++ or a lot of other languages. Basically, a package is a way to create variables without having to worry about them affecting other projects or maybe dependencies that you're loading and stuff like that. So a package is kind of just a namespace. So how we'll define a package is we'll do def package. We'll give our package a name. We'll call it basic-test. And then we'll use use CL. Now what this is saying, use, you can kind of think of as saying like, give me all of the symbols, quote unquote. So symbols are basically, you can kind of think of them as basically all of our functions and all of our macros and everything like that. So we're saying, give me everything that's available in the default Common Lisp library. So that gives us access to pretty much everything that we normally use in Common Lisp. So now if we just go ahead and evaluate that, or compile it, sorry. Now we have created the package basic test. Now we can do in-package basic test. And if we compile that, then we are now saying that the current instance is in the package. Now say if we did something like def var x is 10, we compile that, and then we say in the REPL x and hit enter, we will find that x is not bound. And the reason for that is that currently the REPL will almost always just start you in the Common Lisp user package. Now to actually tell the REPL to use our basic test package, we can just go ahead and copy this into the REPL. Or what you could also do instead is, let me just go back to in-package CL user. So going back to the CL user, if you are using sly or slime, you can do Control-C and then tilde. That will sync with the current package that you have. But make sure that you have actually compiled this. If you don't compile this guy and you try to run that, it won't be able to determine what package you're in because it doesn't exist yet. Now, one last thing on packages. Something that you'll see a lot of projects like to do is instead of having this def package at the top of the file, what you'll see is that a lot of people often will create like a package.lisp, and they'll put all of their def packages for each of their different files, just in one file. So it can kind of act similar to what you'd see with like in C, there's a .h file. That would kind of act somewhat similar to how you would expect that to be functioning. So you kind of get like a little layout of the API rather than having to look in every single file. Now, if we really wanted to, we could jump into the deep end, but for now we'll be doing some rapid prototyping. And this is kind of the nice thing about Lisp, is that while I did create these directories, it actually doesn't matter. Theoretically, I could have just made this main file and just started writing code. It doesn't really matter. And so what we'll be doing now is we'll actually be doing some really quick ways to iterate and use different dependencies. So our project is going to depend on a few dependencies that are out there. The first one is Ningle, which you can kind of think of as a little web service framework. It's basically a way to define URLs that the user can go to and what to return them when they go to them or when they post them and stuff like that. This will make a bit more sense in a second. If you're not comfortable with this sort of knowledge and stuff like that, don't worry, it'll make sense in just a second. And the other dependency that we will need is Clack. Clack is basically a simple wrapper around a web server. So for now, the default web server that it uses is Hunch'n'Toot. Which of you guys have ever used like the Common Lisp ecosystem very much? You've probably heard that term before. You've heard the package, and Clack basically will wrap that, but it also has support for a bunch of other web servers. So it kind of just makes things a bit more abstract. And personally, I just like it for that reason. I'm not saying that this is what you need to be using. That's just what we'll be using for this project. Now, in order to install these dependencies, usually if you're like a Python developer, you'd use pip. A lot of C libraries you have to actually install with your package manager. If you're using Rust, you'd use Cargo. If you're using Node.js, you'd use npm. Now in Common Lisp, we use something called Quicklisp. Quicklisp is basically the package manager for Common Lisp, and it doesn't actually function the same way that you'd be used to in a lot of other languages. A lot of other languages, you'd access it via a command line, but since obviously as Lisp users we love the REPL, that is actually what we use to load our projects. Now, if you're using Roswell, you'll have it already available. If you're using SBCL or any other Lisp implementation other than Roswell, it shouldn't have Quicklisp available right out of the gate, but I will post a link down below on how you guys can get Quicklisp set up. If you guys really need it, I could make a video on it, but the instructions are fairly straightforward. Now, Quicklisp can be actually used to install a project, which is basically a collection of these different packages that we are creating. So when we create each of these packages, because basically usually your project will contain more than one package. And so when we put all of our packages together to create a library, that creates a project, and then we can make that project available on Quicklisp. And then Quicklisp itself will make it available to everyone else, and then they can quick load it and install these projects very easily. Now let's go ahead and actually install these guys. So actually from the text editor, we could just do QL quick load. And so this is how we actually tell it to install and load this dependency. So we'll do Clack. And then we will also do Ningle. All right, and so now if we just evaluate that, it will go ahead and, there we go, and it will go ahead and load Clack and Ningle. Now we have those both available. If you guys didn't have them downloaded, then it would just take a bit longer, and it would just go ahead and pull those from the Quicklisp repository, which basically has all these projects available to you. So now that we have these dependencies loaded, we're probably going to want to be able to access them. So let's just go ahead and delete that, and we can go ahead and access them in a very simple syntax. It's actually pretty reminiscent of what you see in a lot of other languages. So we'll go ahead and do a def var, and we'll call this app, and we'll do make-instance. And so this is basically a way to make an instance of a class. This isn't anything new so far. Now we will need to give it the name of that class, and that is a Ningle app. So basically what we're saying here is it is under the namespace of Ningle. We're basically part of the Ningle package. And then we're trying to access the app. So you know how we defined that? So we did def var x before. Now if we just did basic-test : x, we can actually access that x from before. Right? And if we just hit enter, we'll see that it is 10. And so basically this is how you can access it externally. The reason we use 2 colons here is because it's not actually exported. We didn't do anything to make it available outside of our package, but we'll go over that later. So since we can access this with 1 colon, we know that Ningle is actually making the app class available to us. In fact, if we wanted to look a bit more into what's happening, we can actually hover over this guy and go to the definition. And we'll actually see, oh, it's def class called app. And if we go to the package, we'll see that it is under the package of Ningle/app. And this is all exported later on in some way. Now, just to make the basis for our actual application, we will want to define a route, which is basically a format for the URL that when someone types it in and they go to it in their browser, they will be able to, that will actually get given to us. So basically what we'll want to use is setf, assuming that you guys are somewhat experienced with Common Lisp. You've probably seen setf before. It's basically a way to set a value of a variable. So we did setf, that same x to 20 and evaluate that, and then we did x. We'll see that now it is 20. So it's basically a way to manipulate the state of the application. So now what we'd want to do is we're going to do ningle, and then we're going to give it max, or let's do limit, and then method. Actually, I don't think we even need that part. So this should be enough to basically get us started. So what we have here is we're basically defining a URL for our application called limit. Now we could do something really simple. Let's just call this guy hello. And then if we do a there. So now if we just go ahead and compile that, we have now just defined a route. So if we actually did clack up app, and then we want to do, actually the rest of this seems fun. So let's go ahead and compile that. Now we've actually started a server, and then we want to go to /hello. And now we get hey there. So basically we've defined the URL. If you can see down here, I know it's really small, under /hello, that is what we've defined here. So now we can go ahead and define another route, and we'll call this limit. And this is how we will actually define our API. Our API will be super simple. It'll basically just randomly generate a number based on the limit we give it and return that to us. So since this video isn't really about ningle, I decided I would just go ahead and skip over that previous part. But basically what we're doing here is this part is accessing the actual value that's in here. And it's storing it in limit. And then basically we're making sure that limit is a number. And then if it is a number, it will randomly generate a value and return that to us. So if we go to the same URL, but instead of hello, we do 15. Oh, whoops, forgot to compile that. Go to 15, we will get a random value between 0 and 15. So if we refresh the browser, every time we refresh, we will get a new number. Pretty cool. So if we did maybe the same thing, but we did never, we will get invalid input never. So that's basically what this is doing right here. And as you guys can see, I didn't actually restart the server. The server just kept running, so we didn't really have to do anything. So as a result, we could actually just keep iterating. Maybe if we didn't like the look of this and we wanted to do like dash in there and refresh it, we'll see that the changes we make are, as soon as we compile the function, replicated. So that's pretty awesome. Okay, so it looks like our application's looking pretty ready to go. I don't really think that we need to add anything else to it right now. This is enough of the code to actually get going. Now we need to actually build out our project to be a proper, well-defined project that we can hand to Quicklisp in the future and maybe distribute via Quicklisp or distribute it as a binary. So you're probably wondering, okay, Quicklisp seems pretty cool, but how does Quicklisp know what dependencies are needed for our project, and how can we make our project understandable for Quicklisp? Well, this is done using a pre-existing project known as asdf, also known as another system definition facility. Sorry about that, I always forget what the F is for. asdf can be thought of as basically a declarative build system, kind of similar to something like CMake. So here's kind of the structure that you can think of it. You have a project, which is kind of what we're loading with Quicklisp like we were doing before. So when we quick loaded clack, that is a project. And a project contains a set of systems, which are usually dependencies or maybe a bunch of other ASDF files and stuff like that. You'll kind of know what I mean in a sec. And then a set of systems all contain a set of packages. So every time we're defining each of these packages, which is basically, in a lot of cases, a package is just basically a file. In a lot of cases, every time we're defining these packages, there is a set of them that will be defined for a system. And then a set of systems is used to create a project. I know it sounds kind of confusing, but once you've done it, once you start to actually do it, you'll understand what I'm talking about. Now, this is where those template projects that I was saying that we'll talk about later will be a bit more helpful. But for now, we'll go ahead and actually create a system definition really quickly manually. So to define a system, we will go to the root of our directory. So we're at the very top of that basic test, and we will go ahead and edit the file basic-test.asd. Okay, and then we will do def system. And so as you can see, I'm already getting completion for asdf. And we will give our system a name. We'll call it basic-test. Now we'll give it a bunch of dependencies that we needed before. So we'll do depends on, and then we will give it a list. And that list will, I guess the list can just be like this. It'll depend on clack, and it will depend on ningle. And then next we will want to list its components. So components, that is basically a list of lists. So if you just had something at the root of your project, I'm actually pretty sure you could just start writing stuff in here. But since we have a source directory, we need to give it a module of src, and then we have a component, and then the components contain a list of lists once again. And all right, that looks pretty good. So this might seem a little strange, but basically how you can think of it is every module is basically another system, is kind of how you can think of it. So every system has a set of components, and a module is basically another directory in this case. So source is the next directory down, src, right there. And the components in that system contain just the file main. Or actually it would be main.lisp, but since it's just assuming Lisp at the end, this is fine. So there we go, we've defined a system. Now you're probably wondering, how exactly can I access this? How can I load my whole system all at once? What do I do now? So usually what people would do to make this project available is they'd put it under their local projects directory in Quicklisp. That basically is under the path home/quicklisp/local projects, I believe. So you could put this directory under there, but I prefer to actually just have it insert it there manually via the REPL. So in order to do this, you can just go ahead and run this command. Basically, we are pushing the current directory into the local projects directories for Quicklisp. If I just hit enter, we have now, so yeah, here's the path to my local projects directory, and now we've added another directory to that. Now, if we wanted to actually load this whole project, we could just do ql quick load, and then the name of our project, which is basic-test. Oh, my mistake. It has the src right there. So we just want to do a cd. So change the directory to here. There we go. And now if I do this, there we go. Now we've got our actual one. And now if I did a quick load, it will load our whole project. And as you can see, it even starts up the server, which is probably not really what we want to do when this is loaded. So instead, let's change the actual format of our code. And let's go ahead and just do, go to my main.lisp, and we're going to go ahead, we're going to leave these definitions, but we are going to make a function called main. We won't take any arguments for now, and all it will do is start our application, right? And now if I just save that and we go back to our asdf, this is all good. Okay. And so now if we save that, we can go ahead and do, let's go ahead and just do a quick load now. And there we go. So it didn't start a server this time. So pretty straightforward. Now really quickly, I just changed the port number just to, make it so it's not just using the default. Now if we quick loaded this again, we now should have basic-test : and then we should have access to main. There we go. So we do have access to main now, which is exactly what we want. Now we can actually use this to create an executable. So going back to our ASD file, we will do a build-operation, and we will do program, and then we will do build dash. We'll just call this basic, actually instead of basic test, let's call this basic rest. Just to add to the confusion. We're just gonna call, this is what the executable name will end up being. And then we'll do entry point, basic test, : main. So basically build operation, this is just saying create a program with this when we want to build it. Build path name will be basic rest. You know what, let's just make it test, just to, because this, I feel like that's just too confusing to change the name now. So we'll do basic test, and then the entry point will be basic test main, like we had just a second ago. So it'll call this basically when we want to execute the, create an executable. And so finally, if you wanted to kind of build this, you would go ahead and you would just do, can actually make a little build script or something like that. It's kind of like, there's a lot of ways that people like to do this. We'll do a build.lisp. And what we'll do is we will just go back to this guy, push. Okay, so we'll go ahead and just copy all of the commands that would be needed to run this. So we'll need to quick load this, and then finally asdf make. And so this is kind of like the same idea as running make in a make file. It's kind of the same idea here, basic test, all right? So now if we save that, we can actually run the command if you guys are using raw as well, or you could basically execute this with whatever Lisp you want and just load it. So what we'll do is we'll do raws-l. Okay, just a few corrections that I just realized that I missed. We just need to include this dependency. This just kind of fixes an issue with when it tries to use Hutchintute. And then in our main, or our source main, all we need to change is add a little loop here, and this will just basically prevent the program from exiting since this starts in another thread. All right, there we go. And so now if we did that build, this should be good to go. In just a sec. There we go. Finished building. Now we can go ahead and we can run it just like this, listening on that port. Let's give this a try. And we just need to change the port number to 5. There we go. All right, and then if we kill that, oh, I didn't handle that part, but you could probably add some extra stuff just to handle that. Control C, but if we refresh, it is now gone. So cool, there we go. So now we have built a standalone executable. It's not exactly perfect, but this is a pretty good starting point for those of you guys who want to start building executables. Now, one thing that this current setup does miss out on is version locking, which if that is important to you, I'd recommend looking at qlot and CLPM, which basically both offer the ability to version lock your packages and your dependencies to make sure that there isn't any version inconsistency, but that might not be necessary for you guys. And I don't really know if I want to include that in this video. That might be a bit out of scope and a bit too much to put all in one video. Now, really quickly, let's just show you guys how you could do this a bit faster. So just going to go up a directory. Now, starting up a fresh REPL. If we wanted to start a project, what you could do is you could just use quick load cl-project. And there we go. So now that I've got cl project, you can do cl-project, make project. And then this gives you the ability to provide a path. So we could do basic. And then we could also, basically you could do like name of the project is place, description, basically anything like that. You can pretty much do it all through this. And so this basically gives you a really simple way to do this. And you can do like depends, and then give it like a list of clack. And then if I did that, and we cd into basic place, you'll see that now we have like a tests directory set up. We have an asdf made for us, or an ASD file, and we have like a README, we have our source, and we have our main. And so basically all of this stuff will be set up for you. An alternative is a CL cookie project, which I think has a better base template, but a CL project is a bit easier to access. It's a bit more extensible. But yeah, so, and with CL project, you can also like define your own templates, which could be pretty helpful. Anyways, guys, I hope this gave you a good introduction to how you guys can create projects for Common Lisp and how you guys can get started making your own command line projects, maybe a graphical user interface, anything like that. You guys can go ahead and now, hopefully, you have enough of a starting point to know where to go. I just wanted to give a big shout out and thank you to Palantinus, Tall Guy Jenks, and Carr for supporting me on GitHub sponsors. And finally, I wanted to thank Connor G for supporting me on Patreon. Thanks again, everybody. If you want to support me, links will be down below. I'd really appreciate it, and it helps me keep the content going. Anyways, guys, thanks, and I'll see you next time.